So, good morning. While you do these warm-up problems, I will come around and I will be collecting your homework from last night because I want to give it back to you right away today if you had some wrong on it so you can work on it this weekend. Okay? So, 2 warm-up problems to start, me collecting homework to start. So, first one on the warm-up problems, we first need to decide what type of equation we have. Our choices are regular, exponential, or logarithmic. It's exponential. Why is it exponential? Sure. Not just because there's an exponent. No. Why is A an exponential equation?
Because the exponent has a variable.
Because the variable is in the exponent. Yep, that's what makes it exponential. Okay? So, yesterday, and again, I will stress this at the start of class because it made me cranky in the last class. Okay? All of the answers to all of the questions that I ask you today can be found in your notes from the last 2 days. Okay? Right? So if you don't know, you should be flipping back and forth. Okay? I promise you that if you took notes, and everybody takes notes, right, David? Yep. If you took notes the last 2 days, you have all of the answers to today's questions. Okay? I promise. I'll do pinky swear. Okay? So, first step in solving an exponential equation is what? Isolate. We got to get the exponented term alone by itself. Do we have that? No. We got that 4 in front, right? Isolate means it's just nothing in front, behind, below, or above. It's just that term with the exponent on it. Okay? So, we have to do what in this one? Divide both sides by 4. That gives me e to the 3x power equals 1/4. Do I now have my exponent term isolated? Yes, so we've done step number 1. Step number 2. Switch forms. Okay? I'm in exponential form, means I need to go into logarithmic form. Log, what's my base? What's my base in this problem? E, right? So it's going to be log base E. Do we write log base E? What do we write instead? Natural log. Okay? So it's log base E of what? Of 1/4 equals 3x. Natural log of 1/4 equals 3x. Then, to solve that, so that's step number 2. Step number 3 was solve, right? So I solved that. I'm going to divide both sides by 3. So that gives me the natural log of 1/4 divided by 3. That would be my exact form. Okay? Or, if we scroll up to get it. Calculate it on a calculator, we get approximately, if we round to 3 decimal places, negative 0.462. Yes, If I multiply negative 0.462 times 3, I get negative 1.38629. If I take e to the negative 1.38629 power, I get 0.25, or 1/4. And if I multiply that by 4, I get 1. So I've checked it. So either one of those I would accept as an answer. Okay. Second one. Choose the equation. Log, exponential, regular. Why log? Why is it a logarithmic equation? What is it? Because it says log. Exactly. There's a log in it. Okay? Alright? So it's a logarithmic equation. That gives me 3 more choices then, right? Because there's 3 different forms of logarithmic equations. There's single logs, log equals logs, and 2 or more logs with extra stuff. Which one of them is it? Single log one, right? Because there's only one log. Okay? So step number 1 in that one was isolate, just like it was in exponentials. Okay? And are we isolated? Yep, we are isolated. Step number 2 was switch forms, right? Okay, so let's switch forms. What is my base? 3. What is my exponent? 5. What is my argument or number or hashtag or whatever we called it from this week? Okay. 3 to the 5th power is 243. Log base 3 of 243. What exponent do I have to put on 3 to get 243? That's 5. 5 is equal to 5. Okay? Questions on either ones of those? Awesome. It's awesome. Okay. Today I would like to do some more involved type solving problems. Okay. We can handle them. Again, all of the stuff, so the questions that I ask you today will be in your notes from the last 2 days. Okay. So, solve for x. First thing before we even get started, we have to decipher what kind of equation we have. Regular, logarithmic, exponential. Because there's a log. Logarithmic equations have logs in them. Okay, so it's a logarithmic equation. Love it. Second thing that we have to decide before we can start is, now that it's a logarithmic equation, which of the 3 forms is it? Single solitary log, log equals log, or 2 or more logs with extra stuff? Which one is it? 2 or more with extra stuff because of this plus 1 at the end. If this plus 1 was inside the parentheses, then it would be log equals log. But that plus 1 is outside the parentheses, so that's extra stuff. Okay? So 2 or more with extra stuff. Step number 1 in 2 or more with extra stuff is what? Two or more with extra stuff. Get both logs on one side or all the logs on one side, right? Okay? So I need to move this log to the other side. So I'm going to subtract it. Log of x minus 5 equals log, oops, tap the brakes, not minus, or not equals, minus log of x minus 2 equals 1. I agree. Step 2 of 2 or more logs with extra stuff. Condense, get it down to one single solitary log. Agreed? Okay. So, do I have the same base on my logs? Yes, that means I can condense them into one. Now this one is from Monday. Okay. When I'm subtracting 2 logs, what do I do with the arguments when I'm condensing? You sure? When I'm subtracting 2 logs, what do I do with the arguments when I'm condensing? You just divide them, right? I divide the arguments. Okay? So this becomes log of x minus 5 over x minus 2 equals 1. I've condensed it down to 1 log. Step number 3. Switch forms. What's my base? 10. Because when its base isn't written, we assume it to be 10. Okay? So it's 10. What's my exponent? 1. What's my hashtag argument answer? Whatever you want. My big fraction, yep. So now I'm there. How, oh how, are we going to solve this? How do I solve 10 to the, well, first off, what is 10 to the first power? 10. So we just call it really 10. So how am I going to solve 10 equals x minus 5 divided by x minus 2? Solve that. There you go. MDX, how would you solve that? But I wouldn't multiply top and bottom. I would multiply left and right sides, right? So you're going to multiply both sides by x minus 2, right? Okay? So if I multiply the right side by x minus 2, I just get x minus 5, right? If I multiply the left side, I'd have to go 10 times x minus 2. Now what? How? What are we going to do first? What? Wrong word. But right, you're on, yeah, distribute, not factor. Factor means we pull it out. Distribute means we put it in. So we're going to distribute it, yep. You want x's to go left and numbers to go right, or x's to go right and numbers to go left? X to go left, did I hear? I like that. I like x's left. Can I reduce 15 over 9? Yeah? To what? 5/3? Which is 1.6 repeating, correct? Yeah? With me? Is that my answer? What do I have to do now? What's my very last step? Step 5. What do you got, Lexi? Check it. So if I go way back to my original problem, way up here, if I put 1.6 into my problem, very first one, if I put it in there, 1.6 minus 5 is what? (1.6 minus 5 is what? Negative 3.4, right? So log of negative 3.4. What's wrong with that? That part can't be negative. My base can't be negative, and my argument can't be negative. So what happens with my answer? What happens with this thing? Doesn't work, so it gets thrown out, and what's left over? Say it louder. No solution. Can't put 0 here, because 0 is a number. No solution is the answer. Questions on that one? Love it. Love the participation too. Okay? Try that one. Hi. So, logarithmic, exponential, or regular? I should throw a regular. I should have thrown a regular on here to freak you guys out. Logarithmic, exponential, or regular? Which one is it? What you got, Lex? Logarithmic, because there's a logarithm in it, right? Natural log is a logarithm. Log base e. Okay? Type 1, type 2, or type 3. Single log, log equals log, 2 or more with extra stuff. Log equals log, right? Okay? So in the log equals log case, my arguments have to be equal and my bases have to be equal. Do I have equal bases? Yeah, base e, right? Okay? Which then means that my arguments have to be equal. 3x squared minus 3 equals negative x minus 7. Okay? I have a squared term, a non-squared term, and some number terms. So let's get everything onto one side. So that would be 3x squared plus x plus 4 equals 0. Here, dear. Okay. Right? Can it be factored? Can't be, right? Okay, so since it can't be factored, what do we have to use? Quadratic formula, somebody just whispered. Yep. Okay, so x is going to equal the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. 1 times 3 times 4. Or 4 times, so 4 times 3. 12 times 4. 48. 1 minus 48. Negative 47. Do I need to go any further? Do I need to go any further? Yes? No? Maybe. What's wrong with it as it stands? What you got? There's a negative inside the square root, which means what? I, imaginary numbers. Do I need to go any further? No. What's my answer here? No solution. Okay? Because it's imaginary. No solutions. Okay? What the heck?
That shit's no solution.
What?
There's no solution.
Nope, there is a solution to this one. Darn, right?
Condense it down.
Condense which side down? Left side. Let's condense the left side, right? Okay? If I condense the left side, adding logs with the same bases, I do what with the arguments?
No, it'd just be log equals log.
But
That's what you're asking?
Well, no. If I when I'm adding logs, so I'm looking just solely on the left side here. So I am, which one? That one. So I am just looking at that right now. When I'm adding two logs, what do I do with the arguments to condense them into one? Multiply. Okay? So this becomes log base 2 of x minus 3 times x plus 1 like that. Now, what kind of a problem is it? Now it's log equals log. Okay? Now, go for it. So, log equals log case. We set the arguments equal. This side becomes x squared minus 3x plus 1x is minus 2x, then minus 3 equals 6x minus 18. Got to get everything onto one side. X squared minus 8x plus 15 equals 0. And then that can be factored. X minus 5, x minus 3. So x minus 5 equals 0. So x is positive 5. X minus 3 equals 0. So x is positive 3. Agree? Okay. So let's start with the positive 3 one. If I put 3 back into my original equation, I get log base 2 of 3 minus 3, which is 0. Right? Do I know what log base 2 of 0 is? Is there an exponent that I can put onto 2 and get 0? Is there one? I don't know of one. So then let's try change of base formula on it. What's log or natural log of 0 divided by log or natural log of 2? Try it. Calculators. Try it. Natural log of 0 divided by natural log of 2. Or log of 0 divided by log of 2. Okay. I thought you were going to say no, it doesn't work.
Oh.
Does it work? Nope, doesn't work. We get a domain error, right? So that one, be gone. Which means that one, be gone. Okay? Then, now let's try 5. 5 minus 3 is 2. Log base 2 of 2. Right? What exponent do I have to put on 2 to get 2? Logie? 1. So that's just 1. Okay? 5 plus 1. 6, right? Log base 2 of 6. Don't know it, right? Calculator, log of 6 divided by log of 2. Natural log of 6 divided by natural log of 2 gets me somewhere in the neighborhood of 2.58, correct? Okay. So this left side is equal to 3.58. Okay? Alright. Then I gotta put it in over here. 6 times 5 is 30. 30 minus 18 is 12. Log base 2 of 12. I need to figure out what that one is. Log of 12 divided by log of 2. Natural log of 12 divided by natural log of 2. Should be in that 3.58 range. Yes? Checked out. Works out. Final answer is just x equals 5. Okay? So, some of you are going to get 3 things today. Okay? Thing number 1 was your yellow sheets. I have not put those in the grade book. You got one back if you need to make some fixes on it. I'd like those fixes made by Monday so that you can fix those, turn those back in on Monday. Or if you get it done yet today, that's fine. Thing number 2, you should have gotten back the cream colored sheet. Oops, one more. You should have gotten back the cream colored sheet again if you did something of the wrong in it. Okay? Again, those can be fixed by Monday. Again, those are not in the grade book either. Okay? And then you're getting this brown worksheet for today. Okay? So those 3 things can be done.